Today our topic of conversation is potential energy and kinetic energy. Now, if you've had a physical science class, potentially even back in middle school, you've probably already talked about potential energy and kinetic energy. And so part of today's lesson may actually be review for you, and that's okay. In our initial discussion, I want to make sure, again, that you understand where the units are coming from, because that's going to be really, really crucial as we get into some of our later calculations. You were told that the formula for potential energy, and you'll recall that potential energy is stored energy. It's the energy that is available to do work. And we think of this in terms of something that has potential energy as far as the fact that it is sitting up above a surface and then has the ability to fall and act on something, or has the ability to turn into some other kind of energy. So potential energy, for the purposes that we're going to be using it for, is mass times the gravity times height. Okay, so if we think about units here, mass is normally expressed in kilograms. Gravity is 9.8 meters per second squared. So I've got meters over second squared. And then my height is going to be expressed in meters. So that's going to give me kilogram meters squared per second squared. And as we talked about the other day, that is going to be exactly the same units as a joule. So as you can see, energy and work have exactly the same units. So make sure that you tuck that little piece of knowledge in the back of your mind, because it's going to be very, very important. Okay, so potential energy is stored energy, energy that's ready to be used at some point to do work. Kinetic energy is energy of motion. So kinetic energy, the formula for that is 1/2 times the mass times the velocity squared. Well, let's analyze these units. Again, your mass is going to be in kilograms. Velocity is going to be in meters per second, and then if I square that, it's going to be meters squared over second squared. Well, lo and behold, kilogram meters squared per second squared was the same units as I have for potential energy, and that's the same thing as a joule. So potential energy, kinetic energy, both have units of joules, and that is the same as the units that I have for work. Why is that? Well, if you think about it, if you do some work on something, you're going to be able to increase the energy of an object. Let's say that you have a toy car and you shove that thing across the floor. Well, if you shove it, you're putting a force on it. It's moving through a distance, so you've met the definition for work. You shove it across the floor, you have increased its kinetic energy. And so therefore, your work and your energy need to be in the same units. Similarly, if you take some sort of an object and it's sitting on the floor, and you lift it up and you sit it on a higher shelf, have you done work on it? Absolutely. You've exerted a force. If you exert an upward force, that's the same direction as the object is moving. So that meets our physics definition of work. And so in doing that, in doing that work on the object and putting it in a higher location, I've increased its height, which therefore has increased its potential energy. So work and energy are very, very closely related to one another. Now, I am going to go ahead and work through example 8.3 for you so that you can see just a simple calculation of how these formulas work. Example 8.3 says a 6,675 Newton car speeds down the highway at 37 meters per second, and it asks us what the kinetic energy is. So what I know is that the weight is 6,675 newtons, and I know that the velocity is 37 meters per second, and I'm asked what the kinetic energy is, okay? Well, kinetic energy is 1/2 mv squared. So in order to find the mass, I'm going to have to get that from the weight that I have been given. So I know that weight is the mass times gravity. So I've got 6,675 newtons equals the mass times 9.8 meters per second squared. And then if I divide both sides by 9.8 meters per second squared, I'm going to get a mass of 680 kilograms. Okay? Now that I know the mass, now I can use my formula for kinetic energy, which is 1/2 mv squared. So I'm going to have 1/2 times 680 kilograms times the velocity that they gave me, 37 meters per second, that quantity squared. And so if you type all that in your calculator, again, that's going to give you kilograms, meters squared per second squared, which will be in joules. So the kinetic energy, when you type all that in, will give you 470,000 joules of kinetic energy. Okay, so real simple calculation there. You just have to make sure that you have the mass and then calculating the kinetic energy. It's really pretty easy to do.